So we know that to tackle climate change as a pressing environmental issue requires that as a planet, we examine and make tough decisions about what we use for energy resources. So, what we're going to be starting with in our study of energy resources are fossil fuels. And the reason that we're starting with those is in the United States, they make up about 80% of the energy resources that we use. So, let's get into a little bit about them. So the characteristics of fossil fuels is, of course, that they're all energy sources. And so the underlying words are the things that you need to be typing or writing in. So they're energy sources. Now, they are a non-renewable resource, which is kind of interesting because you hear fossil fuels. They are created by once living creatures. So you might be like, well, aren't those renewable? And if you remember from our from our natural resource checklist that we just did, that they are all classified as non-renewable. They cannot replace themselves through reproduction, and it takes millions of years in the rock cycle to get buried deeply under the right temperature and pressure in order to have them form. So there are fossil fuels forming on our planet, but they cannot reproduce and replace themselves. Now, this is something that is potentially new to you. All types of fossil fuels, no matter what type, contain carbon. And so here's the reason that that's so important. That when you burn them to release their energy, the carbon combines with the oxygen from the atmosphere to make carbon dioxide. So if you think back to our sources of carbon dioxide experiment and how my car exhaust turned yellow in the bromothymol blue, the reasoning for that is burning that fossil fuel in my engine actually gives off carbon dioxide because the carbon in the fossil fuel is combining with oxygen in the air in order for burning combustion to take place. So the next step that we have is just to learn how fossil fuels are classified. And it's honestly super simple. They're classified by their state of matter. So first of all, we have solid fossil fuels, and really there's only one. There are different varieties chemically of coal, but coal is the general term for it. And coal, so you're typing in coal, coal is created from buried dead plants in the rock cycle. So right now in swampy areas, think like our eastern corner of the United States, Louisiana, for example, South Carolina too, you have these swampy areas where this plant material is getting buried, 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 buried. Now it takes millions of years, but over time, those dead compressed plants in the rock cycle become coal, which is actually a sedimentary rock. Sometimes you hear it called an organic sedimentary rock because it comes from living creatures. Now let's get back to this carbon thing, right? So plants do photosynthesis, right? So they actually take carbon dioxide, mix it with water, and give sugar and oxygen. Well, what's sugar's chemical formula? C6H12O6, carbon, right? So plants are actually taking carbon dioxide and creating carbon compounds in them. So because these fossil fuels come from dead plants, they're carbon-based. And the primary use for carbon on our planet, excuse me, I misspoke. The primary use for coal on our planet is to burn it and to make electricity. So I can remember my grandma's house when I was little. Her basement actually had a coal cellar. Now she had a more modern furnace in her house at this point, but originally when that old house was built, they had to like put coal into the furnace. So not so much use for that anymore, more in power plants. Okay, now here's where it gets a little tricky, right? There's one solid fossil fuel, we call it coal. Okay, look at this list. So liquid fossil fuels are different. So you maybe have heard this term right here, petroleum. Petroleum is the liquid fossil fuel that's taken directly from the earth. It's also known as crude oil. But now here's where it gets tricky. Petroleum can get refined into many other fossil fuels. So based on the length of the carbon chain at an oil refinery, they heat up the oil, and it ends up based on the length of the chain being able to be physically separated. So within a barrel of oil, there are gasoline compounds. There's also jet fuel, which has a different length of the carbon chain. Now, some of your families might have cars or trucks that run on diesel. So diesel fuel is not taken right from the ground. Petroleum or crude oil is another name for it, and then it's refined into diesel. Also kerosene. Most of my students that have used kerosene before, they talk about using it in like a camping lantern. So, still, these are fossil fuels, which means they're made from creatures. So, that means they're carbon based. But generally, this is happening from dead, buried sea animals. And so, think about where oil is taken from the ground. We think of it a lot in the Gulf of Mexico, right? Texas, Louisiana, those places, not the only place, but that's because it's right there by the sea, which is the source for where these animals are sinking to the bottom, getting buried in the rock cycle over tens of millions of years, getting buried deep enough to the right temperature and pressure to turn into oil. I know a scientist that sometimes visits us, and he says that, a real one, and he says that it would take, like, we've asked him before, so how much petroleum could you get out of like a shark? And he says about a little tiny thimbleful is all. So lots of dead creatures in order to create crude oil. Now, our final one, think about what we have already, right? Solid fossil fuel coal, liquid fossil fuel taken right from the ground, petroleum, also known as crude oil. So we have one last state of matter, and that's gaseous fossil fuels. And this one's easy to remember the name, natural gas. So natural gas is taken right from the ground, and just like oil, petroleum, it can be refined into other things. And so it's the natural gas is heated to different levels, and these specific chemicals can be siphoned off of out of the natural gas. So methane is one, butane, and propane. So let's talk about where we would have maybe experienced these. Our furnace at home runs on methane. So if you have a natural gas furnace where the pipes just come into your house, it's probably running on methane. So heating our homes is very much a burning of a fossil fuel. Now, some of you live out in the country enough that you have this big white propane tank in your yard that the energy cooperative comes and fills. So that's a little different chemically, but it still is a gaseous fossil fuel. At our house, we don't have one of those. We live in the country, but not super far out. And we use propane though on our gas grill. So you might have seen like those propane tanks beneath your grill. And then honestly, butane is found in lighters. So if you ever have um, noticed how a lighter works, the butane in the lighter is actually a liquid. And that's kind of weird, but it's pressurized within there. And then as soon as you go to light it, the pressure is released and it turns into its gas form. So these are similar to oil in this way. Remember how oil was made from dead, buried sea animals? Same thing here. This is more animal-based than it would be plant-based. So here's our study of fossil fuels. We're going to learn next, how do they actually take fossil fuels and turn it into electricity at a power plant?